handed these out on Friday, but I hadn't scanned them, so that's why I needed to collect them again. So this time, I've got the digital copy of the paper. Yeah, I just hadn't scanned the rest on Friday. Record. Okay. So looking through attendance, Michael, here. Evan, here. Chase, here. Parker, Brandon, Dawn, Michael, here. Cody, here. David, here. Aaron, here. Danny, here. Adrian, here. And Josh. Okay. Okay. So, reminder for the agenda for this week, check out the calendar. Today we'll be lecturing, I'll be talking about joy. I'll also be talking a little bit about how to deal with this object ID, how to validate it. And we'll be talking about how to use middleware to kind of simplify this process. So middleware is kind of an addition onto that to reduce the amount of code that this requires. Okay, so we'll be talking about those two sorts of things. So a little bit of this, kind of goes back to Express, where we introduced middleware. So if that makes, if you're losing track on that, you may want to go review the section on learning Express.js about middleware. Okay. So that's kind of the gist for today. Tomorrow is a lab day, so you'll be working on 4.2 today and tomorrow. Hopefully we can get through everything pretty quick today, which is not too much. On Wednesday, I'll be talking about child entities and how do you have like data that is nested and kind of how does that fit in with APIs and things you might do. So we'll talk about that on Wednesday and get you started on 4-3. On Friday, I'll be out and Evan will be covering 4 that lab day. So it's kind of just quick summaries of what's going on. I got my work ethic log kind of updated, so that's in sync again on Inside Ranken as far as the work ethic course is concerned. So there's a few comments about just different people, definitely take a look. Part of that is because day 40 is coming up and we'll need to have our kind of mid-semester meeting on that. So helping get kind of prepped for that. Okay, so let's talk about joy. The other thing I wanted to briefly look at is just kind of looking at some of the comments on perusal. So I jumped into some of the discussions. One of the discussions that you print layout. So one of the discussions was kind of, we got started last week, about Mongo and getting connected, and so that's a good thing. We're finally kind of tying some of these things together, right? So we've got Express, we've got Mongo, we've got databases, we've got our web apps, we've got our APIs. We're starting to see the picture come together, right? So is everybody kind of understanding where we are in the process and such, how things are kind of fitting together, the kind of building blocks? We don't have the full picture yet, but hopefully it's kind of starting to come together piece by piece. There's a lot of different information from here and information from there and information there that you just kind of gotta slowly piece together. Okay, so that was that. Another question we need to kind of talk about, test and prod, what does that mean for deployment? We still need to go over how to deploy things to Heroku, and I haven't figured out where the best place to fit that in is. So maybe next week is the best time to kind of look at that. You've got some working applications, so maybe we can get that issue tracker out there next week. And there we kind of need to talk about, what does this mean in different environments? I've kind of alluded to it, and the documentation's alluded to it as well, but we haven't really talked about that and all that means. So need to come back to that. So asynchronous code, yeah, the discussion there was posts on Discord and there. I really want to do an example of kind of what it would look like between the two. But I don't know if we have time to do that today. So I'm going to kind of move back to that. So yeah, joy. We need to talk about this. So one of the things that just, to call to your attention, this joy, what we're going to learn and use today is all about making our validation easier. It's about making our validation code easier to write. So far, we've been doing it just with if statements. We say, if this, then blah, if this, then blah, if this, then send this error, right? And so that means you're basically writing an if statement for every possible area of scenario, right? And so if I have 5 different fields with 3 different ways that can be wrong, potentially you're writing 15 if statements to cover that. All the stuff we're going to talk about today, you can do entirely without joy. Let's just be clear about that. It's not absolutely essential. It's not the only way to build this. Joy is not the only way to implement this. All of the stuff can be implemented without joy, just so we're clear. But I'm asking you to do it and giving this as a tool because A, it does drastically reduce your code and actually helps avoid a lot of common pitfalls. And one of those common pitfalls is something called, kind of pushing extra fields, where you say, hey, I'm going to push a field that doesn't exist and try to set that, right? And so that's one of the things we want to try and avoid. We want to say, here are the only things that are valid. You have to send them, or they're optional, and they have to be in a certain format. So it allows us to kind of define the constraints around the data. And so specifically the way that joy works, right? Remember when we defined the database originally in relational databases, we had to define what we called a schema, right? The schema defined all the table structure, what the columns were, what they had to be named, what their data types were, all those kind of things. Well, that's something that we kind of like, right? We kind of liked the ability to say what fields should be there and what type they should be. But that is something that we lose with Mongo because it's not structurally, doesn't enforce schemas in the same way. Makes sense? So what we're trying to introduce is a tool that basically can allow us to define the schema, but define it in code, right? So that means we're defining and validating the data in the server in our JavaScript code instead of validating it and constraining it in the database with SQL. Does that make sense? So it's a trade-off. And actually there's a lot of value to that because part of what happened has historically happened with relational databases. Remember that we have 3 tiers, right? We talked about this pretty heavily last week. But we have 3 tiers to our system, right? So we have kind of a bottom tier, we have a middle tier, and the top tier, which are kind of communicating with each other. Does anybody remember what those 3 tiers were?
client on the top or the browser on the
Client,
top?
okay. Sure, we can call that the client. That's a decent name. I also sometimes call it front end. The back end or the server, what were you going to say?
Oh, this is the last one.
Yeah. So server, back end, either of those apply. I'm going to use the term back end and front end because that's kind of a more industry standard, but you can say client server there too. Client, server, right? And what was that back layer? That's the database. Okay. What were you going to say, Cody? Okay, cool. So we've got those three kind of layers. Okay, now traditionally what's happened is we've actually needed to do validation logic in all three. If you use a relational database, you do have to validate the data here, here, and here. Oftentimes it's the exact same checks, right? But unfortunately it's not the same code because they all use their own different languages and tools, right? So even unfortunately, the code that we write to validate on the back end is not the code we write to validate on the front end. You can kind of see some of the issues, right? So on the database side, we say, hey, we're going to define a schema and constraints. So we might define this in SQL. Yeah. So I might define that as my SQL schema down here that does my validation. And so if you don't match up with the schema, then the database can throw errors, right? So if the column's defined to be a varchar and you give it varchar 20 and you give it 40 characters, well, the database will give you an error saying, I can't fit it because 40 characters doesn't fit into varchar 20, right? So that can throw you errors because you don't match the schema. Or you're trying to pass a number as a string or vice versa, you're kind of mixing up the data types. So that can throw errors. We also then would, in addition to that, do validation here, and we might use if else in our language of choice. So in this case, we do it in JavaScript, right? We'd say, if this, then throw an error. Otherwise, or et cetera, et cetera, et cetera, we'd go through step by step and we'd say, hey, we need to make sure it's a number. We need to make sure it's not a number. We need to make sure it's positive or negative, or the string doesn't have a length longer than 40 because a length longer than 40, or sorry, length longer than 20, because that would mess up with our varchar 20 down, right? Which it turns out the errors that this produced are generally not user-friendly. And we generally don't want to pipe them on as well, simply for the reason that it exposes a little bit too much information about your database. Even if it were user-friendly, it tells you too much. Does that make sense? So when the errors are generated here, we don't really want to pass those up to the front end, right? So in order to avoid errors here, we have to do them here. Other things can happen where, for instance, maybe you get through part of the process and because you didn't validate the data, half of it gets committed to the database and the other half doesn't. And now your database is in an inconsistent state, right? That can happen. Like maybe one insert statement succeeds, but then an update fails. So we have to validate here. There's no way around that. Like validation has to happen on the back end, okay? The other reason that validation has to happen on the back end is because we can't trust the front end, right? We can't trust the front end because somebody could be using Postman instead of my website, talking to my back end here, and they can send in whatever data they want, right? I don't have any control about what somebody does in Postman or other tools. Huh?
You're totally right. Somebody could decide whatever they want. Postman.
Who send it wherever they want. So I cannot trust any of the data coming from the client. It is completely untrustworthy. Curl is another option you can use to send things like Postman. It's a command line tool. There's a ton of tools that hackers use to build their own front end that completely go directly to the server because front end doesn't matter. So we have to do validation here, right? There is no way to around here. So validation has to happen here. That is a non-negotiable. Because if I don't have that, I can't trust the application. I can't trust the security. I can't do it. So that's a strict requirement. On the other side, hey, with the database side, right? If you're using SQL, well, SQL requires you to do essentially a certain amount of validation on the back end for performance reasons, right? Performance and correctness, right? So what we've seen, right, with SQL, it's required, right? The validation here has to happen, but with a NoSQL database, it doesn't necessarily have to be any validation down at that lower level. We still have unique constraints, right? So you're still going to see unique indexes down here, which can cause issues. So for instance, if we want to enforce that every user needs to have a unique email address, we do enforce that down at this level. There's actually no good way to enforce that in the middles here. We can check, but for all we know, we might check and say, hey, that email is free, and then during the time that you're inserting, somebody else registered that email. So even if this does a check, it's not guaranteed to bypass this check here. So you can and you should do a check, but you have to anticipate always that you might get an error here for it not being unique. Cool. Here we're going to call it MongoDB. We call it a unique index. In the SQL world, we call it a unique constraint. Right? Same idea, different terminology, because we kind of use a different syntax to set them. Okay? So we have to remember that. I might write that down here. Unique constraint. Okay. So we've got that. And so, part of the benefit of moving the validation out of here and here is basically that I don't have as much duplication, right? I don't have the same logic for validation here and there, which reduces how much code I need to write and how much code I need to keep in sync. And the synchronization is actually a pretty important thing because one of the things that happens when we want to push out new code is that we want to say, hey, as I'm evolving the application and adding additional features to it, those additional features often require me to make changes to the schema, whether to add data, to remove data, to modify the data type, to add additional tables. There's a lot of things that happen that can change your schema, right? So I might say, hey, there's our customer wants this new feature, and so to support that new feature, I need to make some changes to the schema. Well, okay, so I have to make changes to the database schema, and I also have to make changes to the validation up here. Those changes have to be in sync, right? And so I kind of do that in what we call the development environment. You do that with the developers. The customers don't see that initially. And so we maybe walk through that. We kind of iron out the cakes for 3 months, 1 to 3 months, as we're kind of in that development process. Testers look at it, et cetera, et cetera. And then eventually we need to take that and promote it to what we call the production environment where the customers see it, right? And so that means I need to take both of these, all 3 of these pieces, and promote those changes to the production environment. So I need to update the database, I need to update the server, and the clients. I need to update all 3 of these pieces in sync to make way for those new changes. Does that make sense? So one of the things that traditionally has meant, if we say, hey, I need to modify the database, if I modify the database without modifying our backend, more than likely our servers now, our application's offline because it doesn't know the new table schema anymore. It doesn't know what the new validation constraints are. It doesn't know the new table, the new column names, etc. So traditionally with relational databases, if you just update this, your whole application is broken. A very good chance that your whole application is broken. Whereas, if I need to update both, right? Cool. So I need to put both of those out there. And so that means, yes, I need to do a build of both of those things. That means that where my code is at has to be in a stable state. This has to be good code, right? I have to synchronize both of those changes. So I have to make a change here and make a change here. Do those at the same time. Often actually meant some amount of downtime, where you have to say, well, these changes to the database are going to break the application, or just changing the backend would break the application. So I have to take the whole system offline, the whole website offline, until both of these things have happened. Does that make sense? Until both of those things have occurred, both of the changes have been made. And so that might be a minor issue. Maybe you can say, hey, we're going to schedule an hour of downtime late Friday night, right? Maybe 5 p.m. Friday night, or 6 p.m. Friday night, so that maybe we don't have any customers in that system. Of course, then if anything goes wrong, you're now having people do overtime and potentially running into the weekend to fix those issues. Right? So issues can arise there. The other thing that happens with the development environment is, that's an issue in the production environment. We have to do that. Well, now we've also created the same issue actually in development, because if we are, let's say I've got a team of 5 developers, one of those developers needs to make changes to the schema in the application. Well, if they make changes to the schema without the application, or application without schema, now the other 4 developers are potentially sunk and can't work because the application is completely broken, right? Because the code that they have for this doesn't match the code that they have for this. So that means things like, hey, when you have to do things like when you commit, make sure to commit both of those parts, right? If you commit half of the thing and not the other half, then your code is broken. And believe me, I've seen that happen in the real world. I've seen developers commit this and not that, or that and not this. It's happened. I've seen it. And I haven't done it too many times myself. I'm pretty cautious about that, but I've done that too myself. It's easy to do. It's easy to miss those changes, especially when you're cherry picking what you're pushing. Or if you're trying to make the changes to the database directly, just using something like Workbench, then that's an issue. You've got to make the changes to the schema and get them up into version control. Okay. So there's a lot of gotchas there. So the key problem there being that, if you make changes, the application breaks, right? And so that's where this sort of switch, if we switch over to something like Mongo and we switch over to JavaScript where things are kind of dynamically typed, actually, a lot of times with Mongo, you can have your developers have different versions of the code, and they can still work with the same database. Because of the kind of more fluid, less constrained nature of MongoDB, you can have these two developers here. I have a version of the application that assumes that the users have a full name, and this other user assumes that they have a LinkedIn profile. They disagree on that, but the code can still work against the same database. Because you just say, well, LinkedIn is optional and your full name is optional. Okay. And we'll fix it later. We'll migrate the data once all those changes get done by the developers involved. We'll kind of mix them together, and then we'll make those fields effectively required from the application side. But we don't require them from the database side, right? So it's huge, right? It's huge to move the validation from here to there. Makes it a lot easier to work with other developers and a lot easier to manage the deployment and the migration of those changes. Does that make sense? So that's where that fits in. So effectively, we're going to get it here, and Joy's kind of going to give us this ability to define a schema at this level, right? That in some ways looks very similar to how we would define it down here, but it's going to be defined in JavaScript instead of SQL. Okay? So that's what we're kind of trying to do. We're moving the validation from this level up to this level to make it easier to manage our applications. Make it easier to work with developers. All right, so that's one thing. Before I kind of talk about then what Joy is, I also should mention what's up on the front end. So up on the front end, what language are we using primarily?
Are you talking about React in the future?
Well, let's assume that we don't have React in there in the mix yet. HTML, CSS, and JavaScript, right? So up here, I am dealing with HTML, I'm dealing with CSS, I'm dealing with JavaScript, right? So the validation logic that happens there is very much user-facing, right? That is what we might say is our first line of defense. It's not the line of defense that we really care about or not our primary, because this is our primary. The middle back end is always your primary, but this one also is usually one where we want to define some validation. I mean, defining validation in some sense in the front end is an optional thing because we're already doing it down here, right? So it is possible that you could just say, well, let's not do any validation up here. We'll just always send the data to the server and let the server figure it out. We'll display the error that the server shows. You can build an application like that. It absolutely is true. But you need to find some way to display the errors to the user, right? If nothing else, you have to find a way to display it to the user, right? So that requires some amount of JavaScript code to do that. And some CSS to style it, because you usually want to make it look red or otherwise call it out so the user knows it's there. Usually also involves modifying the DOM, right? Modifying the HTML on the page to show that error, right? So it actually ends up touching all three of those pieces, the HTML, the CSS, and the JavaScript, to make the error appear, right? It's not just one or the other. So the next question is, okay, so I said I don't have to do validation on the front end. It's not strictly required, but we generally do. Why might we want to do validation up here if we're already doing it down here?
Probably save a trip to the server.
Save a trip to the server. That's one reason.
Can you repeat the question?
Why might I want to also do validation up here in the front end if I'm already doing it in the back end? So that is one reason. I want to save a trip to the server.
Could it prevent attacks? Because I know we talked about before how a hacker could potentially put an SQL query within a field and then send it to the server of the database.
So let's say I block them from sending SQL up here, but I don't block them here. Then I just use Postman and send the SQL query directly to the backend. Right. So yes, that is one thing we want to block. We want to block code injection attacks of varied forms, and SQL is one of those. But we have to do that down here. It's actually in the middle tier where that has to happen. You can put some checks up top, but usually your checks for that can't be inherently too thorough up here, or don't need to be. Okay. So yeah. So the biggest part here, validate. So we validate for a few reasons. So we validate to say bandwidth. If we reduce the number of trips that we make to the server, then we can serve more customers effectively, right? And so that helps. It also helps reduce lag in general between, if you have to send it to the server, you have to wait for the server to do the processing and to send it back. So you kind of reduce the amount of time between when they submit and when they see the errors. So you can reduce lag, and you can just straight up get quicker feedback. So things that you can easily do on the front end, if I'm looking at user, well, on the front end, I can capture anytime the user presses a key, right? Anytime they press a button. I can capture anytime the user makes a tiny little change to the data and then go validate it immediately. So I can actually do that and very quickly just say, oh, this is correct or this is incorrect. So I can very quickly update the UI without making another trip to the server. Does that make sense? So the reason we do it here is because it makes it look a lot more snappy to the user, right? Otherwise, it'd be a little bit slow. Because oftentimes the trip around to get to the server, depending on how much you're dealing with, might be anywhere from maybe 100 milliseconds to 2 seconds, all depending on what all is going on and different things like that, right? And so 100 milliseconds might not seem like a lot. It's usually not too noticeable, but it is really noticeable if you put it in every time the user presses a key, right? So if I say every time the user presses a key, go do this thing, you see they press a key and then, oh, the keyboard's not responding. And then they press a key and then they see the key appear, right? So we've got to kind of manage that. Cool? Does that make sense? So from a user friendliness standpoint, that's why we're doing it in both places. But because this has to deal with the front end, HTML and CSS, and the middle tier, this back end, can't know anything about the HTML and CSS, inherently that means the code is a bit different. Does that make sense? Inherently the code is a bit different. Like for instance, up here on the front end, I have access to Bootstrap, and I'm going to need to use Bootstrap versus I'm not going to do anything with Bootstrap in the middle tier. Okay, all I'm going to say is here's the data. Here's the error message. You figure out how to display it. Okay? All right. So that's kind of the gist. So let's look at Joel. Okay. If you're reading on with where we're at, you go to perusal. Open. So into building REST APIs, I am going to go down to here. So I'm down on page 21 is where we're starting. So jumping down to page 21. You can find Joy on NPM. So if you look up NPM Joy, you can find the package. Unlike some other packages, you might notice, though, there isn't much information here, right? So as far as what's actually available on NPM for this package is really sparse, because so they've moved all the documentation over to another website, which you can kind of see here. Visit the joy.dev developer portal for all of the documentation. So you can get it here, there's really not much. We can see a few things, just to call out your attention. 4 million downloads is a really popular package. Pretty much every project almost every project using Express is using this package because it is that popular. And they're on version 17. Yeah, last published is 2 months ago. So it's still kind of in active development too, which is a good thing to see. right? They're still getting bug fixes. Okay, so let's go over to the website just to kind of show you how to navigate around this. Because I'm going to give you some documentation, some stuff in the reading, but you're likely going to want to read more about it in addition to the stuff I've given you, right? So if we look at the documentation, here's the home page. You can kind of see there's a link to get started with Joy. If we follow that link, it'll lead us into this sort of introduction page. So we know we have to install this package, just like anything else. It doesn't say that here, but that was back on the NPM website. So one of the things we need to do is first install Joy. You can then see that there's a require. This one's kind of unusual because usually when we see a require, remember we use the same name on both sides. So like config, it's lowercase config equals lowercase config. But here, the way the documentation works, it's Joy with an uppercase J on the left and Joy with a lowercase j on the right. That's not strictly mandatory, just so we're clear, right? It is perfectly valid to start your file as the usual way of writing it. So const Joy is equal to require right. If you want to write it out that way, there's no problem. There's no reason that you can't do that. And I've done that on some projects before. It's fine. The downside of doing it this way is because all of their documentation is with an uppercase J. And so my experience trying to write it this way is that it gets confusing when I try to read the documentation. All the documentation is different and I have to remember to translate it. So I would recommend, I would strongly ask that you do it with an uppercase J, even though that's not strictly required. That will at least keep you consistent with the documentation. Okay. The uppercase J basically comes from the idea that this is a class. And so you're calling static methods on this class. It's kind of borrowing its naming convention from, say, C# or Java. Java kind of follows this naming convention, even though we don't see this all that commonly in JavaScript. Okay? So that's kind of what they're trying to indicate with the uppercase J, is that this is a class. Okay? And then we treat it as a class. So, the kind of API for Joy is actually really pretty simple, the basic understanding of it. So what I want to try and do is just kind of try and build some example things before we kind of look at how we apply it with Express. Okay, yeah, so you can just kind of understand the basics, right? And so there's basically a three-step process with Joy. Is we define our schema, we get the data that we're going to validate, and then we do the validation. Right? So we get our schema, we get the data we're going to validate, and then we do the validation. Okay? So let's kind of see that and work that out. What I'm going to do is I'm going to make a new folder on my desktop. And I'll give you this code when I'm done. So you can just take notes. So on here, we'll say, I'll call this Joy example. Okay. So I'm going to open that up with code. And I need to start out a little package.json. So I'm going to do npm init-y, remember, to get my package.json there. Okay, so good. And the next thing I want to do is just npm install Joy. That'll be enough as far as the setup is concerned for here. And so you can see I've got Joy installed now is 17.4.2. Okay, so that's as much as I'm going to do with the package.json for this example. Now I'm going to create a new file, and let's call this validate number. React.js. Okay. So first thing I need to do, now that I've installed Joy, I can start by importing it, by requiring it. So const joy is equal to require joy. Okay. So I've got that in there. I now want to define some sort of schema. So let's start with a simple schema. So I'm going to say const schema is equal to joy. And so I start with joy. It's kind of get access to all these methods. The next thing I need to do is say basically what data type do I expect, right? So here I kind of said with the name of the file, I want to validate a number. So I'm going to say joy.number, right? It needs to be a number. I'm going to start with that as a very simple schema. Const data is equal to 5. Right? So I've got my schema, which I'm saying it needs to be a number. I've got my data is 5, and let's go test that now. So I'm going to say take the schema dot validate. Okay, and so you'll notice that there's two different versions of validate. Validate returns an object, and validate async returns a promise. Okay, it's actually possible to use either of those APIs. I'm going to actually use the synchronous API as far as this class is concerned. I've gone back and forth. There are some distinct differences between the async versus the synchronous. I think having worked with both, I've gone back and forth. I think at some point I thought I was more comfortable with the async. I think the synchronous is maybe a little bit more comfortable. Part of the difference is the way they return errors. So the synchronous returns the error, the validation errors as an object, versus the asynchronous version of it throws an exception, basically. That's the difference. So it changes how you have to deal with the errors. So I'm going to do validate there, and then I need to validate the data. So I take the schema, and then I validate the data. Okay, that's your basic version you always have to do. Okay, take the schema, validate the data. From there, I need to save the value I get back. So I often call this the validate result. Right, so the validate result is what schema.validate returns. Okay. All right, so I'm going to take that, and then let's go ahead and just log what the result is. Console.log validate result. And so now that I've got that, I'm going to start this up. So we're going to say node mod validate dash number.js. I'm running this with nodemon so that I can kind of make some changes, make some tweaks, and we can kind of see how it works. So this one is pretty simple, right? So I validate it. I gave it a number of 5, and it says, oh, yep, that's valid. Here's the thing.
How do you know it's valid?
So there's not an error field. Okay. So the validation result has basically has two fields that you know about. It has a value field and an error field. If the error field occurs, there was an error, but generally the value field appears all the time, regardless of whether or not it was valid. Okay. The value is basically what you've passed into it with some other things potentially happening. We'll get into that. Okay, so with 5, that's pretty simple. If I go change this to a string, ABC, hit save, there you can see the error, right? So it gives me back the value that you tried to validate was ABC. In the specific error that occurred, it says value must be a number. Cool. So I can kind of look at that and see what's going on. Now, the way this outputs is a little bit interesting, and that's because when you do a console log, it kind of does some formatting with objects, right? So this is an object, and so you're seeing it's kind of specifying what the type of that is, or details is appearing as an object. So if we want to dig into that further, one of the tricks I often do with logging is I turn it into JSON. So there's a class called JSON in JavaScript, surprise, surprise, which has two strings. So the first string is parse, which will take a string and turn it into an object. We'll parse JSON. And stringify, which will take an object and turn it into JSON, right? Turn it into a string. So if I stringify the validation result, we're going to see a little bit of a better log, perhaps. So there it's not showing us the data types, it's just kind of showing us the data. It's a little bit harder to read, namely because you can kind of see in there that it's not really formatted. So there's one trick you can use with stringify, which is you can tell it's indent. And if I remember, I may have to look this up. I think it's indent too. Let me check this. JSON, stringify, indent. And I always forget how I have to pass that. Okay, so it's the third parameter. So it's null and then the number. Okay, so null, comma, 2. There we go. So if I pass in null, comma, 2, you can see the data kind of better formatted, if that helps. Cool. So everybody kind of with me so far? So that's kind of the object that you're seeing come back. The important thing to see is that there's a value and that there's an error. And so the message of that error is value must be a number, right? So it tells us something there. And so with ABC, that's what we get. You saw with 5, again, it comes out perfectly fine. There's no error field in that case. If I try to do something like don't define the data, actually, I need to set this to undefined. Notice that how it comes back, though. So I set data undefined, and then I validate it and check that that's a number. See that? So there's no value field, because I basically didn't provide any data. And there's no error because, well, there's nothing wrong with this data. Does that make sense? So, huh?
So there's nothing wrong with nothing.
There's nothing wrong with nothing. Yeah, what's up, Brandon?
So is that accepting the undefined value as a number?
It's accepting it as a number. Okay, so the thing to remember, by default, out of the box, things with joy are not required. They're not required. So undefined is allowed, null is allowed, and sometimes empty string is allowed as well. Okay, so like if I change this to null, we should be able to see the same behavior. Oh, well, there it does complain about null. It says null must be a number. If I set empty string, there it also complains about it, right? So one of the things we commonly want to do is make the fields required. If you mark it as required, then undefined is an error. Okay, so oftentimes we have to add additional constraints to the data. Make sense? Oftentimes we have to add additional constraints to the data. So maybe I'd say, hey, let's say 0 divided by 0, that would give us not a number. And you see it says, hey, value must be a number. Right? So I can try some of those values. I can try infinity, which is still showing that up that as null. There it says value cannot be infinity. So there's kind of some checking that it does already for some of those common error cases. So like infinity and nan, etc. Okay? So there's some of those things it does out of the box. So other things you may want to do, let's say I try 0. Okay, so 0 is valid, right? So it's not quite doing the same thing as falsy. right? That's one thing to recognize. So number.required is not the same as a falsy check. It doesn't cover all of those bases per se. It covers some of them, but not all of them. Okay, so let's say we want to maybe constrain this in a way to say that the number must be larger than 0. Okay, so just like we can add required in here, we can add additional kind of constraints to it. So I could say, hey, it has to be greater than 0, right? So greater than 0 now makes 0 invalid, saying that it must be greater than 0. And so one of the interesting things happens here, you kind of see that it gives you a different error message based on what the state of the data is. Like that's built in. So here it says, hey, it must be greater than 0. If I tried a negative value, that would still give me that same error. If I tried leaving it blank, right, must be a number, undefined, must value is required. So there's kind of different error message that comes out. One complaint I will say with Joy is it's not very easy to customize the error messages. They do have some stuff if you really, really go digging. I have been able to change the error message, but it's really clear that the team behind Joy is not concerned with that being a high priority for you being able to change that message. A lot of the expectation with Joy is that you're going to do the validation up here on the front end and provide a nice user-friendly error here and use Joy as kind of a fallback then. So most of the times the user shouldn't be seeing the errors from Joy. They should be seeing the errors from your error message from your front end code. Okay? It's just kind of a stopgap if those two things get out of sync. Okay, so let's say on the other hand, let me go back to 0. So let's say I want 0 to be valid. Right here I've said it has to be greater than. Another method you can use is minimum. So greater says it has to be greater than that. Minimum says it can be equal to or greater than that. Cool? So very quickly here, I can lay out this schema. I can say that this thing has to be a number. It has to be it has to be a minimum of 0 or greater, and it is required. I can also in there optionally add like a maximum. So maybe it's 0 to 100 for like a percentage. So I say 0 is valid, 100 is valid, but it has to be in that range. Cool. And we can see the error message there if I set it to maybe 101. It would say value must be less than or equal to 100. Cool. So you can get a lot of bang for your buck out of just one line of code when that might have required me like 4 different if statements to kind of get duplicate that same logic.
That's weird.
Right? And it's very easy to modify. It's very easy to add and subtract additional requirements as your needs change. Cool? Okay, so that's validating a number. Let's jump over and talk about strings real quick. I'm going to add another one here. New file, validate string.js. And I'm going to basically copy most of that code over. And so here I'm going to say, well, my schema is that it must be a string. So I'm going to say this must be a string. Remember that it's the same kind of place where if I just say Joy string, it's optional. It's allowed to be undefined. So I usually want to make these things required in general, right? When they're optional, when they're not optional, I'm going to make them required. Okay, so let's try run this now. I need to kill this one and run the other one. So nodemon validate string.js. And so there, okay, so it says value must be a string because I have a number here, right? Now, one thing to notice, it is if I just switch that over, 101 as a string is a valid string, okay?
So just because it didn't have quotes around it, right? It was a different data type. A similar sort of gotcha over on the number world. I need to go back to validate number. If I pass 101 the string with numbers, oh, I need this to be, say, 50. There we go. Notice that the string 50 is a valid number. Okay, so the number doesn't actually force it to be that data type per se. Okay, it just forces it to be a valid number, which means that I could parse it, or use maybe parse float, and then use it from there. Okay. Another interesting thing here to note. So this is a string, right? String 50. Look what the value is. The value is not a string, right? So if I look at validate result.value, it's actually gone and parsed it already. So I do have the parsed version over here that I can pull out. So it does do some what we would call transformation on that data. That can happen, but it doesn't change the original data variable. This variable is still a string, whereas what's coming back in validate results is not a string. So back to strings. Okay, so 101 the string is valid, but 101 the number is not, which is kind of weird. There's some definitely weird gotchas with that, which is part of why you want to kind of try this in an isolated environment like we're doing here. That way you can easily reproduce and see how do those different constraints apply, right? Because sometimes it can be hard to test it in a larger application. Okay, so things I might want to do, similar to working with strings, working with numbers, I can also do things like, hey, enforce the length of that string, right? So I might want to say, is it at least a certain length? Right? So let's say I'm having people pick names, usernames, right? Maybe I want to have them have a minimum length of 3, right? So I can do that. I can say here, string min 3. And that will require your names to be there. So I say Joe, J-O. It's going to complain and say it must be at least 3 characters long. So you can very easily put in there, hey, it has a minimum length to it, which often happens with usernames, titles of articles, all sorts of things where you might want to include a minimum length. Commonly, if I don't have a minimum, I will at least say min 1, just to kind of encourage and say, well, I don't want empty strings. I want you to put at least 1 character there. So I virtually always, unless these are optional, actually, I virtually always put a min 1 on my strings. Cool. If I don't have a larger minimum. You can also use a max, and you can say max, let's say 8, right? So I can say that it's between 1 character long and 8 characters long. Notice that's a little bit different with strings, right? Min and max enforce the length of the string, versus when you're using min and max with a number, it's in the min and max of the value, right? Not the characters. Does that make sense? It's not exactly the same thing, even though it's the same thing. Another thing we can commonly do, if you want it to be exactly a certain length rather than a range, I could say, well, the length is 5, right? So maybe I have the user entering a zip code. I want the zip code to be exactly 5 characters long. I could say that that string has to have a length of 5. Cool. So there's a lot of things you can kind of validate using that schema. All right, so everybody kind of following along what that means. You kind of see, how do I validate strings? How do I validate numbers? Okay, so the next step up from there is we can also do things where we validate objects, we can validate arrays. And that's actually what we want to do. We want to validate an object because we want to simultaneously validate all the data that the user sent us, right? And so how does the user send us most of the data? JSON or via form posts. But how does it appear in the HTTP request? What part of the request is all of our data usually in? The body, right? So typically what I want to do is validate the whole body with joy. Okay? It's typically what I want to do. Okay, so in order to do that, I'm going to make another example. And make a new file here. And we're going to call this validate object, because I want to validate an object. So validate object.js. Okay. I'm going to kind of build it up again just so we can refresh on those ideas. So const joy is equal to require, right? So we need to require joy in step 1. Step 2 is I need to define a schema. So const schema is equal to, I need to come up with a new schema. So in this case, we're going to say that it's an object. Okay. I'm going to have my data. And so here I might say, let's start working with a pet. So I've got his name is Fido, and his age is 5, right? So I want to validate both of those fields. I'm going to then get the validation result. Const validate result is equal to schema.validate, and we're going to validate the data, and then I'm going to log the data like we did previously. So I'm going to log validation result. I'm going to use that same JSON.stringify, pass in the validation result, null, and 2. So it's nice and pretty formatted. Okay, so nodemon validate object.js. Okay, so right now, right, initially here, I've got an object. All I said was this has to be an object. I didn't put any constraints on it, right? I could have put in here test is null, and it would be fine, right? There's no constraints on the data yet. Okay, is everybody with me there? So I haven't put any constraints on the data yet. So I need to put some constraints about what makes the data correct and what makes it incorrect. Okay. The only thing that this would do is, let's say I put here undefined, null. If I put here null, it will complain about that. It will say it must be type object, right? Or if I say the data is Fido, it will complain about that because it's a string and not an object, right? So it's just checking the data type, but nothing else. Okay. So the way that I define what fields it can have, there's actually more than one way to write this, just so we're clear. One way you can write this, if I remember right, is you can do this with keys. And I think a lot of the code examples do it this way. And you define the kind of nested constraints this way inside there. I find this syntax here, even though that's the one they use in the documentation, to be incredibly verbose. And so I don't generally write it this way. Okay, so there's a shorthand that's not really documented, which is a lot better. If you just take off the word keys and pass in your constraints here directly to object, if I remember right, that usually results in a shorter syntax. Okay, so in terms of this is short for calling the keys method. What I can give it is constraints for the different fields. So I can say, hey, there's a name field, and I then nest another schema inside of it, right? So we talked about how to validate strings. We talked about how to validate numbers. I'm going to nest some schemas inside of this object schema. So in here we say there's a name, and that must be a string. just as we did before, I want to say, hey, this has a minimum length of 1, and it is required. Okay. Right? So I'm imposing a schema on the name field. Right? So I can kind of nest these schemas. If you understand how to build these schemas up for the primitive types, you can build it up for an object. And so I have a name. I also have an age. And so the age is a number. I can say, well, maybe the minimum age of my pets has to be 1. Maybe I don't want pets that were just born. So maybe I don't allow 0. And I can say that that is required. So I can very quickly kind of concoct a schema for that object. Looks pretty easy, right? And kind of like,
Very.
Right, and kind of like we talked about before, right? If I was going to kind of do all this myself, I might easily have like 1 if statement to make sure it's an object, and 3 if statements here. So I might easily find myself writing 7 if statements just to do the same thing, right? And that would be it would be less readable because my if statements wouldn't really convey what the needs, what the expectations are, right? I'd have to look at the code, all the if statements, and work back to figure out the schema was supposed to be, right? Versus this makes it very clear what the expectations are. Other thing I might want to do, and I think I saw this, I forgot to put that in there too. I do want to make this object as required to at least ensure that it's maybe not undefined, right? The object as a whole. So oftentimes you'll kind of see that. Cool. Okay. So one of the nice things that this does, which we didn't talk about really, is what if I add another field here? That now generates an error. It says test is not allowed. So this narrows it down to say the only things I can pass are the name and the age. Anything else is invalidated. What were you saying?
So that's awesome.
Yeah, that's awesome. So that allows us to stop things like, hey, with your update path, we don't want to allow the user to update things that we don't allow. So like we don't want them to be able to change the classification from that route. We want them to go to the classify route. We want them to, if they're assigning the bug, they need to go the assign route rather than that update route. So I can I can block those things from being updated through this kind of the standard path. I can narrow what the user can change, what the user can pass. Cool. With defining something pretty easy. Okay. So what else? So that blocks that. Now, one of the things you may also want to see is what happens if I say leave all these fields blank. So what happens if all of these fields I pass empty string? Well, if we look at this out of the box, it's just going to say name is not allowed again. So the default behavior with Joy, when you go to validate things, it just finds the first error and stops. Just finds the first error and stops. And that may be for some situations, maybe all at once. In some scenarios, that may be perfectly fine to stop at the first error. Oftentimes, and I would say usually, I do want to convey all of the errors that it finds. Make sense? And so if you want to do that, there's a very easy option you can add. When I call validate, you can add additional options. So the first parameter to validate is the data. The second parameter is some options. So in there, I can pass the option specifically. It's called abort early. By default, this is true. It stops at the first error. And so if I say abort early false, it won't stop at the first error, which means that it gives me all gives me multiple errors. So it's going to say name is not allowed to be empty, test is not allowed, and it doesn't look like, oh, there it is, and I just skipped past it, and age must be a number. So actually it tells me all 3 of the fields are wrong rather than just one of the fields is wrong. Cool. That's super, super useful. It's a little bit more complicated to figure out how to take this and turn it into something for the front end. Because obviously we have to now loop through all the errors and make sure that they get displayed the right way. But this is generally helpful, so I usually do turn that to false in most of the cases, most of the applications. Okay? There's usually enough value in that to go ahead and do it. And so that's the basic overview of how you work with Joy, right? So we define a schema. You can see that, step 1. Step 1, define the schema. Step 2, is to get the data in some sort of fashion. And step 3 is to validate the data. One thing I might mention before we kind of leave here, let me go back to some valid data. So I'm going to pass the name and the age as both strings, right? So we've already seen that if I pass in it as a string, it will go ahead and parse it for me if I just look at the value. Another interesting thing that we can do, commonly with our inputs, anytime we're dealing with a string, I generally want to ignore spaces at the beginning and the end. And so like here, see it's allowing those through. And so I would end up inserting a record into the database with a name that starts with spaces and ends with spaces, and that can cause issues. Or especially when you're dealing with emails, that would be a new unique email just because it starts or ends with spaces, right? So I want to avoid that. And so what you can do is you can trim the string. Trimming it removes any white space from the beginning and the end. So if I say trim, it will remove that, and now it won't be here in the value. Okay, so it won't be there in the value. So that's helpful. And it's also worth noting that also makes things like this, which are just a bunch of spaces, it'll now make that an error, whereas if I didn't trim it, then it wouldn't be an error. It's like, hey, it's a valid string. Yes, it's all white space. We're okay with that. Another thing to recognize in here, if I do, say, Paul Smith, it removes spaces from the beginning and the end, but not any space in the middle. Remember, trim is only at the beginning and the end, not in the middle. What was that? Yeah. So oftentimes white space in the middle we want to keep, and we want to keep the way the user entered it. But in some cases you may have to deal with spaces in the middle, which is a different story. Suffice to say, there's nothing built into Joy, as far as I know, to deal with the spaces in the middle. Generally, the way we deal with spaces in the middle is using something called a regular expression. Really not quite there. Okay? All right. Which maybe I should talk about that now. Let's see. Time is at 1:53. Let's go ahead. I think maybe now is a good time to go take a break. Yeah, let's go ahead and take a break. And then we'll kind of talk about regular expressions and get back into the pet adoption project. So come back at 2:10, and we'll talk about
how regular expressions does. Yep.
So how does our exam grade work when you on inside Ranken split it into two separate grades?
Yeah.
And in the end, when you look at our percentage in the inside Ranken for exam, it's like what 30, 40%, whatever it is. Is that really all of those grades in there averaged together? Like, for example, are you looking at just exam one as a whole, or are you looking at the sub grades? For example,
So exam one is 80 points for the hands-on, 20 points for the theory is the way I set it up. So the whole thing is 100 points.
I understand that.
I've weighted the assignments under exams by points.
I see.
Right, so right now you've got 20% of your exam grade is the theory, and 80% is that out of the 30. Yeah, it's weighted by points. Your labs are also weighted by points. So like some of the group exercise I put in is 50 points for a group exercise and 100 points for an individual lab. So that way the individual labs are worth twice as much as a group project. Does that make sense?
That answers my question. Thank you.
Yeah. So I'm weighting it by point.
Thank you.
I don't know why you went to open the but you have work to do. Yeah, but that's like the ones I did stuff like that. What, seriously? I didn't know you got. Did you like that?
a great book. Yeah, so I was wondering if these were going to be averaged out.
You see it says 98 out of 100.
What piece of this?
Yeah.
I figured you probably were going to combine them into one 100-point exam.
Yeah.
You're making
I figured you just make that inside recognition.
Right. I had to have them separate because one is
It's not even.
inside ranking, one is the word in as a.
You're giving
We'll
me
post it on the inside recognition.
So that's how it is.
I'm just curious.
The other way I've done that is historically.
The jokes ever get old.
They had a section.
No, we're going to the new code section. Or maybe no.
Yeah.
Hurry up and get
On how many things I have.
Also, I noticed the reading on Google is kind of thinning out. As
Okay.
we read the semester, is that going to be the case?
Yes.
We can only see a month ahead.
Yeah. There's two things going on. A, I haven't posted everything, and B, yes, they will be thinning out.
Okay.
And so, as we go on, more of it takes more time to build as part of it, right? So there's less theory and more practical.
Okay.
So that does happen. That's kind of inevitable. That's the nature of the beast. As we front load the theory a bit, and then we switch over to doing more hands-on. So. But I need to post some stuff for, basically the building REST APIs includes covering everything we're going to talk about this week and next week. And then the week after, say about 2 weeks from today, there'll be another reading assignment about authorization and authentication, security related stuff. So.
Happen to regular expressions, but in more seriously than because authorization requires that.
No.
The email aspect of that? Not yet.
Yeah, you don't need that actually. You don't need regular expressions to deal with that. That's just a validation kind of thing.
Oh.
It has more to do with validating the data. In fact, I don't think for this project that you need to use any regular expressions. So.
I'm gonna ask you a question.
Yeah.
Once this data becomes compromised, does it make sense for websites to store like your social security number and stuff like that?
Ooh. Most websites don't.
I know, but like some things like credit cards and stuff like that.
Yeah. So large in part, in a lot of cases, that would be kind of more likely to be illegal for you to keep that data or to have that data. More than likely, you get in legal trouble for having that data, unless you are certain companies or in certain industries where you're mandated to have that data. Right, so there's a dividing line between here's certain companies that shouldn't have your social security number, and there's other companies that are required to have your social security number. Right, so what fits over on the side of needing required? Any financial institutions? Generally, yes. Governmental institutions? Pretty much yes. Health and hospitals and those kind of things? Generally, yes. Right. So if you're dealing with in the medical industry, if you're dealing with financials, or if you're dealing with the government or the military, likely they're going to have your social security number and more likely be required to have it for security purposes to kind of be part of how you're proving your identity. Okay. So there are systems where that is a requirement, but large in part you don't enter that under other places. So like your social media shouldn't have your social security number, right? They just shouldn't have that information. Your stores that go to shouldn't have your social security number. They might, but they generally shouldn't. Okay? So If you cross over to that line, and you're in one of those places that really has to have the social security number, then there's a bunch of laws you have to follow.
Okay, so it's like a separate.
Yes. Those industries have their own set of rules. Like, so HIPAA and a few other rules apply to medical industry. Financial industry has a bunch of legislation they have to follow. You're working under government. Well, government has all its rules, plus the additional thing they put into your contracts and such. So it really depends on what industry you're in about what the rules are. But generally speaking, there's some, like, you can't just let anybody log into the database or see the database. It may have to be encrypted. There may be rules about what servers you can host that data on. So like MongoDB Atlas might work for some companies, but might not work for some other companies because of those servers are not kind of under their control unless they comply to certain laws. Cool. So there's a little bit more to it than just like the code you're writing. It's also about the interfaces and a lot of those kind of things. So does that help answer your question?
Yeah.
It kind of depends on what you're building.
Well, because I know like sometimes the websites will just ask for like the last 4 digits. I assume that was part of like the security of it, maybe.
If they're asking for the last 4, usually they're sending it off to an API that's provided by like the IRS and asking the IRS to validate those numbers, if that makes sense, to validate and prove their identity. So that usually, if they're just asking for the last 4, that doesn't necessarily mean that they have your number. They're just touching with the IRS APIs to verify your identity. So.
Have you heard of billboarding
Billboarding?
in game development?
No.
Where they take 2D. It was common.
Oh, okay.
Face the camera all the time.
Oh, yeah, yeah.
Like in Grass, for example.
Yes. Yeah, I know about that, and I've done that.
Yeah. I found out about the name of it last night.
Okay.
I saw it in a game I was playing.
Yeah.
I was like, oh, so I kept trying to describe it. Finally, I narrowed down my query and
Yeah.
finally got the result. I was like, oh,
Yeah.
that's a recurring word. I better look that up. So
Yeah, there's 2 ways actually to do it. You can basically, what we call it, a 2D surface is called a sprite. So you're rendering a sprite in the game world. And one way to do it is that which actually is the kind of, so the first thing that came first is our graphics engines were very basic, and rendering things in 3D was hard. So they would the first approach to billboarding thing was they just say, oh, well, just draw it directly to the screen. Skip the 3D engine and just draw it on the screen. And so therefore, you take a 2D image and you draw it onto a 2D screen. Which also means that it can't be like behind anything.
Yeah.
Or like it becomes hard to it's like, okay, I've got the 3D world and I've got my 2D, so I can render, if I render all the 2D first and then the 3D, well, then all the 3D stuff's in front. And then, or if I render all the 3D and then render the billboards, well, the billboards are in front. Mm-hmm. It's really hard to have like some of the billboard covered, like some of it in front and some in back. That was the first way to do that, is you just rendered it directly to the screen. And then we got, 3D graphics got more advanced, and so people said, well, that's just a 2D plane. It's a quad in the world. And so you'd walk around it, and you could see it was 2-dimensional. And so, for a period of time, we decided, well, okay, we still can't render enough triangles to actually have that a real-world object. I still need to be at 2D. So I'll make the quad turn as the person moves, as the camera moves. So the camera is here, I have the quad facing this way, the camera moves over there, I'll make the quad here, and if I'm extra advanced, I will change the texture. And so the advanced version of that billboarding is you would do like 8 different renderings of the image. So I'd render the tree, kind of Age of Empires 2 did this. They rendered their horse from here every 45 degrees, so you got 8 pictures of it. And so you just show the right.
It would fade or something between the transition.
Well, there won't be a transition because you can get that in that.
Oh, so it
was literally just
hard,
8, which is like,
wow.
It was literally a hard jump. Yeah, so that was kind of the third version of billboarding. And you still occasionally see that in new games if they're trying to save on resources and it's far enough away. I've seen games still do that with grass and other particles. Dust particles is still usually good enough to do those. Billboarded, you can't really tell. So you still sometimes see it.
Yeah, I remember playing some games like that in the past.
Yeah.
Like on consoles.
Uh-huh.
And playing PC games, so that old enough to do that. But
Mm-hmm.
it didn't bother me at the time, but today it bothers me. I guess because I've just got that awareness, like, hello, why are you turning with me?
Yeah.
It's
Yeah.
kind of fun.
Yeah. Okay. So it's 2:10. Let's go ahead and back talk to this. Okay. So I want to talk a little bit about regular expressions. And do take a note on this stuff. Just a few disclaimers on regular expressions. There's something that we really do, you want to know about that. Commonly called regex, short for regular expression. You're not actually going to need them for the lab assignment here or the test. Just so we're clear on this. This is not something new. They're a really good thing to know about, but they can be a little bit of an advanced topic. I personally have used them in most programs that I've written. At some point, I've gotten to the point where they make sense to add. Okay. Most programs I've needed a regular expression for something or another. They usually come a little bit later into the development cycle. The easy problems like checking for, they're commonly used for things that are kind of regular, common things, standardized formats that you're going to bring in, like let's check that an email address is valid. You can do the regex. Let's check that a zip code is valid. That's one of the easiest examples. Let's make sure that your full name has a space in it. All of these kind of things are really, really common sort of things to do with a regular expression. Or make sure your number only has digits in it and no letters. All of those things can be done. But I tend to not maybe encounter these as much in the intro here, especially because Joy can kind of take care of most of those cases. Most of the common cases for working with regular expressions you can kind of use Joy for. When you need something more advanced, you may find yourself making your own patterns. Okay? So regular expressions. So regular expression is a way of defining what we call a regular language. Is kind of the mathematical side of behind it. In the mathematical world, it's called a regular language. Okay, and it's one of the early ways that we kind of started talking about natural languages and how do we deal with this. It actually ties back to the way we actually write programming languages. The way we build programming languages, the way we build compilers, heavily involves regular expressions for defining every little bit of it. So they come up a lot there. So, and that's one of the main places they've come out. So the kind of idea where regular languages and regular expressions come from is this idea of taking in a string. Specifically, it's talking about strings. You're strictly talking about a string data type and determining one of two things. It's either valid or invalid. There's really no in between, right? With a regular expression, it's either valid or invalid. There's no real in between as far as regular expressions are concerned. Okay? One way we model these, if you ever take a class on discrete structures, you might see this. So we model these and kind of write these and think about these with something called an automaton or an FSA, finite state automaton. I'm going to write that out. Finite state automaton. Okay. Also known as an FSA. So the syntax we use that is we kind of create this, what we call a state machine of different states. So for instance, I say, let's make a old robot that says if it's a sequence of A's, then it's all good, and if it's not, if there's any other characters there, then it's wrong. So I'd start here, kind of at the entry point, come in, and so if it's an A, it goes to this state, and if you continue feeding A's, it stays in that state. Right, so maybe this is state 1. Okay. And so that's valid. If at any point I get some other letter that is not A, say I get B, it would go over here to state 2, which is not a valid state. Similarly here, if I get anything that's not A. Okay. So the double circle implies that this is a valid state. Does that make sense? So a double circle is valid. A single circle is just, this is a pathway around the thing. If your string ends up here, you're not valid. So this would say, start here. If at any point you can see if I end up with not A, I end up in this state. But A keeps me in this state. Cool. And so I actually might have, this would be a starting point, so this would be a state itself. So I come in. Okay. So one or more A's would make this one. Okay. So regular expressions are kind of like basically compile to this. And so what they effectively end up compiling to is a bunch of if statements and a bunch of switch statements, etc. You can kind of think of all of these branches. If it's A looping back to itself, A going here is a switch statement. So it switches based on the character. Okay. Let's talk about how I would actually define this. So the way I define a regular expression like this is I need to kind of declare the sequence of characters we're allowing. So I'm allowing an A one or more times. So that's my regular expression. Plus means one or more times. And then if I did A star, that would be 0 or more. Okay? So I'd say one or more times, 0 or more times, 0 or more times look like this. We start at the valid state, like that. So this would be the A star version. Okay. Another thing that we commonly do, so star is 0 or more, question mark, 0 or 1A. Question mark means the thing before appeared once or not at all. So 0, 1, 1 or more, 0 or more. Cool? So that's what those three special characters mean. Another thing that's worth noting is a dot represents any character, and in some cases it may be except new line. So a dot is any character except new line. That except new line depends on what your settings are. Sometimes it may include new line, sometimes it may not include new line, depending on the settings that you've done on the regular expression. Okay? All right, so those are some starting points. Now, a common thing I may want to do is I might want to say that it is one character or another character. So for instance, I could say, let's say it is a group of characters. So I could say, hey, it's a series of A or B one or more times. So the square brackets define what we call a character group or a character class. And so I say these characters are valid here. A and B, no other characters, multiple rows of. So it could be A, B, A, B, A, B, or it could be B, 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 or A, A, A. Any mix of those two characters is good. Okay? But I have to have at least one. I can continue that, and I can say A, B, C, D, right? That would be any of those four characters is valid. Okay. It's worth noting this is only the lowercase letters. Uppercase characters are different characters. They would be considered invalid. Everybody with me there? Okay. So what we often do, as this kind of grows, I may want to consider all of the English letters. So I might say A to Z plus. So it says all of the letters from A to Z are valid in this group. Cool. I can also include like multiple ranges here. So if I want the lowercase letters and the uppercase letters, then I specify two ranges. Just so we're clear, it is not valid to do this as one range because these are the ASCII character symbols. If you say lowercase a to uppercase z or vice versa, that actually includes a bunch of special characters in between because there's a bunch of special characters between the uppercase letters and the lowercase letters. So those have to be two specific ranges. Clear? They have to be two separate ranges. Oftentimes, I might also want to add in there the digits. So oftentimes you'll see A to Z and 0 to 9. So this would be all the letters and all the numbers. So there's kind of your starting point. Okay. So I'm going to say these group of characters are valid. I can then do a multiplicity on that. 1 or more, 0 or more, or option. Cool. Okay. So anything that corresponds or matches that pattern is valid. Anything that doesn't match the pattern is invalid. Okay. Another thing we can do is I can, let's say I literally put some characters, AB, okay. That says the string exactly needs to be AB. I might want to provide some alternatives, so I might say AB or CD. Put a bar in between, that would be an or. So it's the thing before the bar or after the bar. Okay. We can also use parentheses, so I can say boop, and then followed with XYZ. So it starts with AB or CD followed by XYZ. The parentheses are ignored, okay, as far as being in the actual string. So this would allow the strings, this would allow for A, B, X, Y, Z would be valid, and C, D, X, Y, Z. Both of those would be valid. Okay? But other combinations would generally not be valid. Now, one important thing I need to mention, which I really left off the discussion so far. By default, these regular expressions only have to match some part of the string. They don't have to match the string as a whole. They only have to match some part of the string. So as long as this sequence appears anywhere in the string, or that sequence appears anywhere in the string, that regex would pass. Okay? So what we do is we add some letters to the beginning and the end. And if I remember right, it's the hat matches the beginning, and then have my stuff in the middle, and the $sign to match the end. So this is the start of the string, and this is the end of the string. Okay. Also, depending on settings, this can be the start and the end of the whole string, or the start and end of a line. So it can be the start and end of a line, or the start and end of the string as a whole. By default, it's the string as a whole, if I remember right. Okay. So in the world of JavaScript, I'm going to maybe go to coding here. Kind of talk a little bit about syntax. New file, regex examples. In the world of JavaScript, one more thing worth mentioning, const. Let's say we want to declare a number pattern. So I say number or integer pattern. When you declare a regex, you use these slashes to start and end it. To say actually, I think I've got the wrong. No, it is those slashes. I use the forward slash to start it and the forward slash to end it. You can kind of think of that as just quotation marks. So for instance, if I want an integer, well, that would be 0 to 9, all the digits, 1 or more times. So that would be my regular expression for an integer. I'd want to make sure that that covers the whole string, so I would add those in there, right? And so that represents a integer. Starts at the beginning, 0 to 9 digits, the digits 0 to 9, 1 or more times, and then ending with the string. So if I had this be a star, that would allow empty strings. But I'm putting it as plus to make sure that there's at least one. Okay? So given this, how would you define a floating point number? How would you define a floating point number?
So you just open up another set of brackets, square brackets.
This is a new pattern. What do you mean a new set of brackets?
New square brackets. And we'll put 0 to 9 in there. And we want it to contain at least one number. So it'll be in front of the decimal.
Okay.
So plus.
Okay.
And we'll put a decimal in there. So
now, one catch. Remember that I said dot represents any character.
So we have to escape it.
We do have to escape it, right? So if I just put a dot here, I'm saying any character. I'm not saying it has to be a dot. So it could be a letter, it could be a special character, it could be another number, it could be anything. So I need to say slash to escape the dot. So that says I want a dot there, exactly a dot. What's next? So I have digits, dot. Somebody else give me an answer here.
Another bracket is 0 to 9.
Okay. And how many of those do I want? Okay. Okay. So we can kind of start to declare these. On the one hand, I'd say that once you kind of understand the syntax, they tend to be not too terribly hard to read and kind of figure out. But I think I and a lot of even professional developers have some time kind of reasoning about them in the syntax. They are a little bit harder to test and a little bit harder to read. Regexes are kind of notoriously easier to read than they are to write. Or, sorry, easier to write than they are to read. Easier to write than they are to read. So one thing I want to do is I want to take this out. I'm actually going to use a website that I commonly use for testing. So there's a regex 101. They have a really nifty tool where you can toss the regular expression in the top field here and then insert like what you want to test it against in this field. Now you'll notice it's starting as PHP 2, PHP 7.3, etc. It's in the PHP syntax on the left. So different languages have a slightly different syntax. I want to make sure I go down to ecmascript/JavaScript, which is down here, that third option. So I'm in JavaScript, and let's test it, right? So let's say I put in the number 123.57. Okay, so it's going to go over here, and it's going to say that's a match. All good, right? That's a valid number. Okay. Are there any other valid ways to put in a floating point number? A fraction? So like 3 divided by 4? Okay. That could be. Let's say for our intents and purposes, I'm going to call that invalid. Right? So you see it's not highlighted. That means that it's not passing. It's not matching the regular expression. Okay? Which is good, right? I don't want 3 over 4. I don't want those to match it. What else?
0.0.
0.0. Okay, we've got that one covered. What else?
Yeah, like a 0.0.
So 0.25, right, would be a valid number. Notice that that one's not highlighted. It doesn't match. It doesn't work. Because we're presuming that there's always digits before the dot. So I need to fix my regular expression. The time symbol? Okay. So let's say we do that. Okay. So that works for the examples that we have. But I will say, I'm trying to remember, I know that there's a case that this doesn't, I'm trying to remember, there's a case that that doesn't work for. And it's not immediately coming to me. It may be that it's further along. So 0.25, right? That's a valid string. Okay. I could also put in numbers the other way around. So 1, 2, 3 point with just a dot. It's technically a valid floating point number. So I could technically leave off the digits after the dot. What then?
Or use the star on the other side?
I'm going to use the star on the other side. Okay. So again, that works with the cases that we have. Okay.
Okay, now what if you do nothing and a decimal only, which is not a valid floating point number, but you've led to a situation?
Right. So I could do just 1, 2, 3. I could do just a valid dot. Right now, a valid dot, just a dot, we've made it valid. Right? We've said, okay, 1, 2, 3 is not a valid one, but just a dot is. So we've made the dot required, but we haven't allowed things that don't include a dot. Okay. What now?
You need to put logic in there so that at least one of the sides has a number.
Okay, that's a good question. Is there at least one way, one thing I might think, like, okay, maybe I do a question mark. Maybe I say, hey, it's optional, the period is optional. Could be in there, could be not. Well, we start to see like 3/4 is a valid number now, and we see the dot by itself is allowed. Yep.
Can't we just parse the number we're looking at to a floating point number?
We're trying to come up with a regex. Trying to come up with a regex. Because internally, parsefloat does use a regex. Okay. So what I might want to do, right, so one thing I want to do, notice that the 3/4 is working now. It's actually detecting it as two numbers, 3 and 4. That's because I didn't match the start and the end of the line. So I need to remember to match with the hat at the beginning and the $sign at the end. So that at least eliminates 3/4, right? Something that has that. Similarly, I don't want to allow things like 1, 2, 3, A, B, C, because part of that is valid, part of that's a valid number, and other parts are not. Or A, B, C, 1, 2, 3. I want the whole string to be a number. Okay, so I can start and end with that. That doesn't cover the dot, right? So you're asking the question, what you said you need to ensure that one side or the other has some digits on it, right? But this format that we have at this point doesn't enforce that, right? It doesn't require digits on both sides. Everybody with me there? It doesn't require digits on both sides. So what I'm going to do is I'm going to actually backtrack a little bit. I'm going to say one or more digits, always a dot, and plus. So I'm going to start with something more. I'm going to go back to something more rigid. So this only matches things that have a period and numbers before and after the period, right? So we know that case is good, right? What I then start doing, rather than kind of switching things over to stars, is I kind of decide which parts are optional. So, for instance, I might say, well, a number, there should be numbers before the decimal point, and maybe everything else is optional. So maybe I say, boop, put the second part with the dot and the numbers, make that part optional. Okay, so that covers this, it covers this, and it covers that. It doesn't cover anything that has a period, just a period, like these two. It doesn't cover those two. Just a period and not numbers on both sides. It's pretty close. I can relax this a little bit and then say, well, maybe the part after the period is that. Everybody with me there? So I'm requiring at least one digit to the left, but I'm not requiring a digit to the right. You see that? So that's half of the picture. Okay. If I were to do it the other way around, let me copy this and put this in Notepad somewhere so I have this at least at this state. That's valid. Ignore the GM at the end. Those are settings. And now what I could do instead is I could kind of flip it and do the other way around. So I could say the part at the beginning is maybe optional. Or rather, maybe I could do it this way. Maybe I just say the first part is star, and the second part is plus. So that covers some of the strings, but not all the strings. Right? It covers anything that has digits after the decimal point. Yes?
So that's where we use two regular expressions and say that S magically is one of them?
Yeah, there is. So I can use that, remember that pipe, to say A or B, which is why I saved this. So I can say that's one variant. And put parentheses here. Boop, boop. There we go. I'm going to copy this. That covers both. It might be a little bit easier if I throw some additional parentheses in to see it. And maybe I write it this way. Oh no, I do want it the other way. So I say either it's one or more digits. It could be just that. Optionally, I could add one or more digits, a dot, and that. Or maybe I could simplify this a little bit further and use another bar. Say this is required, and 0 to 9, just digits, are an option. So we've got ones that are just digits, or ones that are digits followed by a decimal point to numbers, or I guess in this case would be just a decimal point followed by numbers.
So even without the first four you just made, just digits 0 to 9, and just one, I'm still passing the case of just digits.
I was just trying, at this point I was just trying to simplify it. Oftentimes you kind of get to a working point, and then you're kind of like, oh, I can ease it up a little bit because I don't need this part now. There's actually, for any kind of valid thing that you're trying to come up with, there are multiple regular expressions that do the same thing. For the most part. Anytime you start to come up and put in these bars, there's more than one way to solve the problem. There's not just like one regular expression that does it. So this is kind of a complicated one, right? So we saw, right, for dealing with integers is just this, right? Integers is just that one. Versus floating point numbers is a little bit, quite a bit more, right?
Integers is one part, right? Because floating point numbers are actually, integers turn out to also be floating point numbers. But there's more formats that are available. Everybody with me there? So you kind of see the sort of syntax, right? Working with numbers can get convoluted pretty quick. Another thing that you'll commonly see, let's say we want to have a username, right? That is, I need to have that and that. Let's say I have a username, and maybe that username can only include letters and numbers. How would I write that out? Let's have a username that can only include letters and numbers.
Brackets, lowercase a to z,
Okay.
and more brackets, uppercase a to z,
Mm-hmm.
and another set of, is it all in the same brackets? Okay.
Yep.
0 to 9.
Yep.
And we'll put a star there, if you don't mind.
Which I do mind empty strings, right? I do want my users to all have a username. Ooh. Okay. So that'd be a good starting point. Remember that I need to have it match the start of the string and the end of the string. So I need to have it, in here, the hat, and the $, and the slashes in JavaScript represent that it is a string. So we've got numbers, we've got floating points, and we've got. Oftentimes, I may allow some special characters in my usernames. So for instance, oftentimes you'll allow underscores in your strings. So I might say allow an underscore. I would add that single character to that. Cool? So you can either add ranges or you can add single characters. Now, here's a hard one. How do you validate an email address? Believe me, this is a hard one. Okay, so we know, let's kind of write down our assumptions. So email address has to include, actually maybe I'll write it this way, has to include an @ sign. Okay, are there any requirements for email address?
Then maybe a dot for the domain.
Saying dot for domain. Okay.
Domain has to be at least 2 letters.
That would be incorrect.
At least 1 letter.
Yep.
Either 2 or 1.
Well, here's what you get into. I think that right now, I don't know that there are any domains that are 1 letter, but there's no reason there couldn't be a .x domain in the future. I don't want to have to change my registration form just because that changed. And now there's users that are like my user.x, example.x. Okay, so I know the domain name should be at least 1 character. Okay, what else?
I'm guessing like the user email could be
Okay.
Before the app.
You mean the username?
Yeah.
Okay. Username has okay. What else?
no spaces.
Okay, no spaces.
I guess, well, what's the point of that? I mean, we're only allowing letters, right? It's not gonna block spaces.
So I'm going to go ahead and just say this, mention some of these rules are wrong. I'll come back to it. Just tell me the rules that you can think of. What else?
Oh, it can have an optional, another dot. It can have two dots. So there's room for another dot after the @ sign. And if there is room for another dot, then the domain has to be at least one letter applied to that.
Okay. Now you just said after the @ sign. Can I have dots before the @ sign? So I'll get back to you, Brandon, in a second. So I saw one person say yes and one person say no. So you said nodded yes and you nodded, Michael, you nodded no? You thought you could and you thought you couldn't. Okay. So why do you think you can't?
I'm just guessing, that's all.
Okay, so you're just guessing. Why do you say you can't?
I feel like I've seen it before with dot.
Okay. Okay. So a common counter example that people don't think of is the John.doe at example.com. Yes, dots are allowed in the beginning. I can't have a dotted name like that, and that commonly happens where they have their first name, comma, last name. Actually, I'm missing that. So that's legal. Generally speaking, okay. There's some argument about this one. John.doe at example.com. Is this one a valid email address or not? So show of hands for this is a valid email address. John.doe.
If they allow decimal, why is there a limit on the number of characters you type in?
So you're saying yes. Just
Yeah.
put your hand up.
That seems so.
Okay, if you think this is invalid, put your hand up. So most people are not voting. Don, what's your opinion? Is that a legal email address? Yea or nay?
It looks weird, but I don't see it. But I don't see why it would be allowed.
Okay. It looks weird, but I don't see why it wouldn't be. What if this is me fat fingering the first thing?
That sucks.
Right? What if this is me fat fingering the first thing? Do you want to tell the user that it's wrong and maybe stop the user from creating an account with the wrong email address? Maybe. Right? What happens if this is actually their email address and now you've just told them they can't sign up? What if this is actually their email address and you've told them they can't sign up?
I feel like that would be an issue that could be resolved within the database.
Okay.
Like putting side by side, like it was that if it's case of one dot or two dots, I
Okay.
imagine it'd be a bit too close
Okay.
to put on there.
Okay. So my question, just walking back, my question was very specifically this. So we make a regular expression that defines this. Let's say we make a regular expression that defines this first one as valid and this one is invalid. Okay. So the user's experience is when they try to register on your website, they enter the second email address and it says error because it doesn't match your regular expression. It says this is invalid. You can't register. You must provide a valid email address. What does your user then do?
They get pissed off and don't try again.
That's a possibility. That's a legitimate possibility, right? If you tell them that their email address is invalid, when it's actually not invalid, then they just leave. They say you have a crappy website. They might leave you a bad review, if they're able to leave you a review on wherever, but they're never coming back, likely, because they couldn't create an account in the first place. Okay? Make sense? So, what does that mean for us? Well, that means
Well, it's just been said, could you kind of eliminate some of that and you can do it twice?
that could help, yes. If I have to enter it twice and compare it, then I can at least eliminate some of the data entry errors, right? Because maybe they won't make the same spelling mistake twice. So I could do that. I could absolutely do that. And that would improve the quality of my data. If I ask them to enter it twice, I will absolutely improve the quality of my data because they're less likely to make the same mistake twice. And that's reasonable. It's reasonable on a registration form to ask them to confirm their email address. There's nothing wrong with that. I would recommend doing that. What also does this teach us? It also teaches us that we don't want to be very strict with the criteria on what's a valid email address, what's a valid name, especially be very wary of validating people's first names or their last names, because if you say somebody has an invalid first name, that's a problem, right? That's a problem. If they say my name is Jay, just the single letter J, and you say that that is not a legal name, you're wrong. If you say that their last name has to be, you say, hey, their last name is, again, just J. The last name could be just a single letter. That's right.
I have remembered before that you said that the domain name could be an IP address as well, right? So there's multiple dots.
Yeah, that's possible. Yeah, that's possible too. And that's true. So the thing to understand, right, when we're validating, we need to be liberal enough that we don't tell somebody like this is invalid when it's actually valid, right? That's extra super dangerous, especially when you're dealing with people's, first names, last names, full names. There are all sorts of weird things that happen. If you try to throw a regular expression on their name, it's going to fail. So we don't use regular expressions just so we're clear on first names or last names. There's too many gotchas there. It's not worth it. Just let them change their name later if they get it wrong. It's much safer to let them change the name later than to try to make sure that they have the right name entered. Now, email address is a little bit more expensive because if they register with the wrong email address, then you're sending it to an account that will never exist, and so that account is basically dead because the email address doesn't exist. So there is some merit to wanting to make sure their email address is correct from the beginning. But I don't want to turn somebody down if they might have a valid email address. So you really want to lean on the side of leniency, not on the side of strictness. You want to lean on the side of leniency, not on the side of being too strict. And that means you're going to let some things through that may or may not be actually legal. Okay? So I think per spec, I'm not sure that this one is actually legal. For the email spec, I don't think the John ... is actually legal. But I generally would just let that through.
Can you also set it up though, like with a validate email? Would that also kind of help?
What do you mean validate email?
Like when they see your email, you have to click on.
Yes, yeah, we generally do that as well. Yeah, we generally do that as well for two reasons. A, because it confirms that they've entered it correctly, and B, it ensures that they own that email address and they're not entering an email address for somebody else. So there's a security side of that too. So I'm going to allow this through. Does that make sense? I'm not going to constrain it and say it can only have the dots have to have characters around. Okay. I'm also going to allow things like 1, 2, 3 at example.com. Because I really have no control over what that is. Whoever owns this website is deciding what's a valid domain, what's a valid username. I have no control over that. Does that make sense? I have no control over that. One thing I can say for sure, there's one thing I can say about this beginning part. And one thing only.
It's unique to that domain.
Not necessarily.
So you can have two the same user?
So actually there's two things. I can say that it has to have at least one character. Now, character in general, I don't mean letter, I don't mean number, I mean character. One character. Actually might be a Chinese character, might be a Japanese character. It's just a character. It has to have at least one character. Okay? That's a reasonable assumption. Because I don't want to have the email start with an @ sign. I know that's invalid, right? If it starts with an @ sign, it's definitely not correct. But it should have at least one character. And that character can't be an @ sign. So I know, let me write this one here, so I have it down. So I know that before the at least one character, and I know there's no ats before the @ right? I know that their username can't include @ signs. That's a reasonable assumption. Okay? I'm sure maybe there's somewhere that has maybe there's an email address somewhere where somebody has an @ sign in their email. I'm okay with saying that just in case we're just going to ignore, because you can only do so much, right? You can only do so much. So I'm going to say that there's no @ sign in here. Okay? Other things that you have to remember to account for. We're just talking about regular domains. When I'm talking about the right side, let's ignore the left side for a moment. I can also have things like www.example.com. That's a valid email address. Actually, would probably point to the same place as example.com more than likely. And I could also have, well, it could be a valid email address. I could also have foo.app, foo.example.com. This would be a case of this domain name. So those are valid. We also have @example. That's a valid email address as well.
just needs to allow a character.
Yeah. So the restriction here, if you say add example, it looks for a computer on your network named example and sends it to that server. So if I have a server on my network, my intranet, my local network called example, it's going to send it to that, look for a email server on there. Cool. Unfortunately, this one, while it is a valid email locally, doesn't necessarily allow you to send to the internet, right? So actually, if they entered this one, it might be valid on their local network, but I can't send them an email because I'm probably on a different domain name. So this would be valid if you're working internally on a same company, but if you're working, which the most common is, websites hosted out here, they have to come out to the internet to send email. So usually that might not be a valid email. Okay. So I don't necessarily want to allow, I generally don't want to allow those. As was also said, I'm going to get some markers because these are dying. This could also end in an IP address. So for instance, 127.0.0.1. Remember, this is sending it to a computer that has a computer that is named example. This is sending to an email server at that IP address. It's perfectly valid for email addresses to end in IP addresses. Most people don't have that, but it is legal. Okay? It's also legal to do that, because that's an IP version 6. That's an IP version 6 address. So actually both of this refers to localhost at localhost 127.0.0.1 and ::1 are actually all the same thing. But they're valid as terms of email addresses. So does that make sense? So it can be a domain name, it can be an IP version 4 address, or it can be an IP version 6 address. These, again, they're legal to spec. They're legal to spec. We're usually okay pretending that those are illegal, and so if our regular expression ends up making them illegal, it's okay. Okay? We don't have to be strict about that, but we don't have to allow it. So, things that means. Okay, so we're saying there's a dot for a domain, so it doesn't necessarily have to be, because it could be : :1, but that's something reasonable to ensure. We're saying that there's at least one letter in the domain name, and the part after the dot we call the TLD. So we can say that the TLD has at least one character. Okay, and I'm actually going to change these and say not letter, but character, right? Because TLD and the domain name could include numbers, they could include special characters, they could include non-English characters. Those are legal, okay, in a lot of cases, or might be legal, okay? So what I'm going to do, spaces, I'm also actually not sure about. But commonly we might put a plus or an underscore or a dash to represent a space. Okay? But I'm going to eliminate that one as a rule. And we're saying it could have more than one dot after the outside. Okay, that's reasonable. But I'm not actually going to do anything with this rule. It's like, yes, it's true, but we're not going to actually necessarily do anything with it. Okay. So the rule's kind of forming in everybody's minds, right? So we start with defining a valid email address. You need to remember match the start, match the end. Okay, so that's a given. And I might start by saying, oh, we kind of came up with this username, and maybe I would slap that at the beginning and say, well, it starts with a username, but we kind of defined and we talked about, well, it's maybe more than that. Okay, so when I talk about what happens before the @ sign, and say, hey, yes, it has to have an @ sign. Okay. In fact, if I just do something like this, that by itself, this says that it is a string that contains an @ sign. Actually, this may be sufficient as a regular expression in some cases. I mean, this is valid for all valid email addresses. It doesn't mark some invalid email addresses invalid, but that is a simple version that does work. If you just say it has an @ sign anywhere, that's version 1. But I want to be maybe a little bit more strict than that. So I need to say, hey, it's got, I need to kind of match the whole thing back to where I was at. I want to say that there's something before the @ sign and there's something after the @ sign. So what comes before the @ sign per our rules?
English only characters.
What would it be if it was English only?
ABC, capital ABC, sort of.
Okay. What about special characters though?
Dot plus.
Okay.
So then that's the last of that.
Right, yeah. So if I say dot plus, that's any character, including the @ sign, right? But what I really want is anything except the @ sign. No. Exclamation point is actually just the exclamation point. Exclamation mark. It's not actually not. So remember, I can define a character class, right? So this would be the character class containing just the @ sign. So if I left it this way, I would just say one or more @ signs preceded by before the @ sign. Good so far? There is a not, and it looks like so. So I say not the character class anything except @. That's it. So I say anything, any character other than @ one or more times. Yeah.
So the original at the beginning is just saying not anything before that, right?
So no, this one is the beginning of the string,
Okay.
and hat in here is not the characters in this group. Those hats don't actually do the same thing. They're two different hats completely. This is one of those things that gets confusing about regular expressions. As I said, they're not the easiest to read. Okay, does that make sense? So that's a simple version, right?
Just within the brackets that has different meaning.
Yes, just within the brackets. If it's outside of the brackets, then it would be this. So like if it was here, then it matches the beginning of the string. Okay, so now you have that. What do I want to put after the @ sign? Okay, so let's say it's the same thing. Not the @ sign one or more times. Does that work? Actually, I mean, this is a valid answer. This is a valid answer. Everybody okay with that? No @ signs, an @ sign, no @ signs. Perfectly valid. Actually, this is not a whole lot more strict than the one above it, but that's a perfectly valid answer. Now, one of the rules that we did say, we wanted to say, hey, that there needs to be a dot over on the right side. So if I want to require a dot, then I need to add a little bit more in there. So I might say, well, there's a dot, and then other things after the dot. Does that make sense? So this would enforce the fact that there needs to be a dot. One of the things that this is kind of not great at is dots can actually fit into here or into there. And so actually there's multiple options for how this does it. So I would actually do that and say after the dot can't be another dot. Does that much make sense? So after the dot, it can be anything except @ the dot. But before the dot, it could include other dots.
That's a problem.
No, that's valid. Because remember, I can have foo.example.com.
No, your solution there says that you can have a dot make text.
I'm okay with that.
Having a dot.
I'm okay with having a dot right next to a dot. I'm going to live with that. Does that kill? Because it would actually take quite a bit more work to prevent two dots next to each other. Or for a lot more would be a lot more. Okay. Are people kind of making sense on this regular expression side? You can see a lot of times you can get away with very simple things. Like I can get away with just a sequence of 0 numbers, a sequence of alphanumeric characters. So let me remove the underscore there. Alphanumeric characters, or I could say, hey, it's just something that includes @ right, and be very loose about it. Okay? Another thing I might mention real quick, in terms of kind of dealing with zip codes. Commonly when we're dealing with zip codes, we have sort of an upper bound as well, where you might say, hey, a zip code has to be always 5 characters long. So you may also see that. And so that says the thing before it is exactly 5 times. Exactly 5 copies of the thing before. Cool? Okay. So if we want to use regular expressions with joy, that would look like so. So I might say email. Oh, no, I want that to be up here. I might say email joy.string.pattern. And then I could provide any of those versions that we wanted. So for instance, if I just say, hey, it has to have an @ and no other rules, then it would look like that and required.
Is required there redundant because if we're undefined, it would match the pattern?
If it were undefined, let me run this so you'll see. So validate.object.js. Okay. So if I don't put required there, this is valid because I didn't specify an email. See that? And so if I say required, so I still need to make that field required potentially. Because for Joy's purposes, it only does that if it's actually there. So then that allows me to do things. Email is Paul Ranken edu, or my actual name, Pierre Smith at Ranken edu. Right, so that allows that through. So that's how you can include your regular expressions. Now, the part of the other thing you'll want to do with the way that regular expressions work, remember regular expressions are kind of hard to read. So the error message that by default Joy gives you is it says email with value blah, 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 fails to match the required pattern, right? And it's actually listing the pattern here. If I were to take my longer version of that, take all that, put that in here. This is not a very friendly user expression, a very user-friendly message at all. Okay. I do not want to send the regular expression back to the user. Okay, everybody with me on that board? I do not, in any circumstance, want to send the user the regular expression because they will not know what to do with it. So, what I do is there's a little less known trick. The second argument to pattern gives it a nice descriptive name. And now it says, fails to match the email pattern. So I can give my regular expressions a name with Joy just by putting a comment there. Definitely do that. If you are going to use a regular expression for anything, name it something. Okay. Cool. Yeah, and it's actually that is such a tiny thing, but such a big thing to users in terms of the error message that they get. Okay. So we'll kind of talk through that. Let's go to the pet example. So I want to go to File, Open Folder. Where did we have a pet option? So Node. Okay, so pet adoption version 2. Select folder. And I need to actually clone my version 3 as well. So, boop. D projects. I'm going to toss that screen. And I'm going to talk about version 2. Okay, so getting into version 2 of this, run start dev. Oh, before I do that, remember before I start my server, I need to install Joy, which I don't think I did yet. Oh, I did. But just a reminder, because you probably have not done this with your packet, with your project, is you'll probably want to do npm install Joy, just to make sure it's there. Okay, now npm run start -dev. Okay, so my server's up and running. Everybody clear here? Okay, if you're rolling up pet adoption version 2, just be clear, I'll give you all this code when we're done. Right, so if you want to just take notes on paper as we're going through that, that's fine. You don't necessarily have to follow along with what we're doing here. So if I look at my routes, remember we have like 5 or 6 different routes, right? The 2 get routes, right? So list, does it take any input data? No, right? So we don't read anything from the request in this list route, at least not right now, right? So because I'm not reading any data, I don't need to do any validation in this route. Everybody clear with that? I don't need to do any validation here. What about this one? Am I receiving any data in here?
Pet ID.
I'm receiving the pet ID, but nothing else, right? Okay. That might be something that I could use Joy for to validate the ID. I'm going to come back to that, and I'm going to try and focus on the body first, right? So if we look through our routes, what you'll notice is about half of these take the pet ID, right? So this get route takes a pet ID, the update route takes a pet ID, and the delete route takes a pet ID. So there are 3 where we need to validate the pet ID, but only 3, okay? The ones that actually read the body are only these 2. We create a new pet and we update a pet. Okay? So those are the 2. The ones where we read the body is where I'm going to start looking at how do we use Joy. Does that make sense? So I'm going to start there. So remember, I've installed it. I need to require it. Const joy is equal to require. And so notice that this is, again, uppercase J for the left side of the equals. So I'm going to const joy, uppercase that, require joy. I'm going to go then into the new route, and let's define the schema. So const schema is equal to what? So if I remember what we had to put there? Joy.object. Okay. And so then I need to clarify what the fields are, right? So what fields do I expect to come in from the body?
We're looking for species.
Okay, so we're looking for species. Okay, what data type is species? What data type is species? It's a string, right? So we're going to say joy.string. We definitely know it needs to be required. What else do we know about the species? Is there anything else we can say?
Have a number.
So what you're saying?
Minimum 1 character.
Minimum 1 character?
No numbers.
No numbers. Maybe. Okay. So I might say minimum 1, and if I want to say it has no character, no numbers, I would need to use a pattern for that. And so I might say, well, start, end, and kind of like we just saw, it would be the opposite. So I just want to say it's not 0 to 9 plus. If I wanted to keep digits, numbers out of it, it would be that simple. I just say, hey, it's anything except numbers. Okay.
What does that plus after the not mean? Can you logically explain that?
What do you mean the plus?
The
This
plus, yeah, I just don't get the plus.
this plus says 1 or more of the thing before.
So it can't contain 1 or more.
No. So it's a sequence, like the whole string doesn't include the digits 0 to 9.
Oh, but it can still contain 1 or more of anything else.
1 or more of anything else.
Okay.
Yes, I'm saying 1 or more of anything else. Yes, what's legal is 1 or more of anything else. If anywhere in there I get a number, then it's no longer valid. Okay, next would be name. And I can kind of do the same thing. If I wanted to prevent numbers in the name, I could also do that, but I'm going to allow numbers in the name. Okay. What is the next property that I need to validate? So what do I need to validate next? The age. Okay. And so age and Adrian is what type?
A number.
It's a number. Okay. Now, in this case, I might want to say that the number has to be a whole integer. So I might say integer. and I also know that it's required. Okay, is there range on the age? What's the smallest age that you can have? Could be 1, could be 0. Either of those are valid options depending on what you're building it for. So we could say, well, the age is maybe 0 years old or 0 days old. You know, maybe it could be legal. We didn't say if we're measuring this in days or if we're measuring this in years. Can I put a max on that? Is there upper limit to how many years old a pet could be?
I wouldn't, because you could have a tortoise.
Okay. Tortoise, what's the longest that a tortoise could live?
That has not been defined yet.
Okay. I mean, could a Galapagos, tortoise be 1,000 years old? Probably not. So let's at least say, let's give it a max of 1,000. I mean, yeah, we may or may not know that, but at least I think for the pets that most people own, they're probably not that old, and especially if they're up for adoption, they're probably not that old. I don't think that somebody wants to adopt a 1,000-year-old dog. Okay, and so I've also got a gender, and so, well, I'm going to say, hey, that's a string, and I could represent this a few ways. I'm going to just say, for simplicity's sake, that it is 1 character long. So I'm going to say it's a length of 1, and it's required. So that way I can put it in as M or F. Cool. So that schema sort of makes sense. Okay, and it kind of makes sense with the data that we already had. Now, I need to run my data through that schema, right? So I might say, hey, we've got the request body, right, is kind of what I want to validate. So I might say, hey, let's go validate, or sorry, schema dot validate, and I could just give it the whole request body, right? If I give it the whole request body, maybe I tell it not to abort early, false. Remember, I need to save that to a variable, so const validate result. So if I take that, that just takes the entire body, validates it, and it will either give me an error or not an error. Make sense? Either give me an error or not an error. So commonly what I might do is I say, well, if validate result dot error, if there is an error, then we're done. So I say return res dot status, and maybe this is a 400 code because you didn't send me valid data, and we say JSON, we say there's an error field, and that is equal to, let's just pass through the validation error. So that way if Joy says, hey, there's any problems with it, we're done.
So now pass the whole object, the error object within the validate result?
It'd be the whole error object. Yeah. Make sense? So we're just taking all of the error data that the Joy provided and just sending it back to Postman. Sending all that data back to Postman. We can see it in Postman and play around with it there. And then otherwise, my pet is equal to the validate result dot value, right? Because remember, value is kind of the cleaned up data. Now, when we're talking about cleaned up data, I didn't do this previously, but I probably should. I should definitely trim my strings. So I want to trim the species. I might want to trim the name and trim the gender. All good? So that's my pet. I needed to then add an additional field, which is his ID. So pet._ID is equal to a new ID. So I kind of re-swizzle it around that way. I think my mouse ran out of battery. So that has now covered all sorts of errors, right? We've covered quite a few different possible errors. And I think maybe I should name this not numbers. Okay, which also means I can now remove a lot of this checking, right? All of that checking to make sure that the user entered certain values has been accomplished. Is everybody on board with that?
Yeah.
So I can take all that out. And that's now been captured by our schema. Okay. So that's the insert route, right? So I insert data, I just need to define a schema, validate it like that. I can actually go to, I should probably go to Postman and give it a quick test. I think I have that query saved, so it shouldn't take too long. So let me go here, create pet. So I'm going to do put request, API pet new. I've got the name, the species, the age, and the gender. I'm going to hit send. And it's all good. It's all happy. If I leave off the gender here, it's going to complain with this error. So we can see gender is required. If I leave it out, if I put it in as male, it's going to say, oh, that doesn't work because the length of gender must be 1 character long. So I can start to see some of those error messages.
So Mr. Smith, instead of passing the whole error object, could you just target the message itself, or do we want to send the whole thing?
We could target and just send the message itself. I'm not going to do that here. Part of that is because this information here with the type and the path can also be useful.
Okay.
Because the path and the type can also tell you, like, this is the reason that it failed, and this is what field it failed for. So that might be helpful for your front end to figure out, like, which field to highlight, right? Or which error message to show. So that information actually can be helpful in terms of the front end.
Okay.
So I'm going to leave that alone for the moment, especially because it would require a little bit more to figure out how to pick out just the parts we wanted. Okay, so I'm going to leave that as is for the time being. And if I check the list route, let's just see if that pet got in there. We should see, yeah, there's the pet that I inserted. Okay, so that's the gist of this. Let's now look at the update route. Well, a good intuition with the update route is that it's probably, when I need to update a pet, it's probably a very similar schema. So I can go down here and I can say, hey, let's bring in that same schema. And if I'm going to require the user to update all of the fields at once, I'm done, right? If I want to say, like, that's the schema I need. Okay, well, let's try that. So I'm going to say in here, we've got the update, which is the body. Actually, I want to do const validate results is equal to schema, kind of what we had before, schema.validate. Take the request.body. We'll just take all of the data from the body, and abort early is false. False. Boop. And then if there's an error, it'll actually be the same thing. So I might just bring that over. Okay, so define our schema, validate the body, and if all of that's good, then we're going to say the update is validate result dot value. And from there, this one's been fixed, at least for the stuff in the body, right? We haven't dealt with the ID yet. All cool? Does that kind of make sense as far as the transition, right? So I've defined the data, and let's try to update that data. So I'm going to go back to Postman. The pet that I created, I'm going to copy that ID, and I'm going to go to update pet. And first thing I'm going to do is I'm going to try and set it with no data. If I set no data, see it says species required, name required, age required, etc. Right? So it's telling me all 4 of those fields are required. If I spell them all out, all good, right? So if I put in valid data, all good. If I don't put in valid data, it gives me an error. Okay, so now remember, one of the requirements that I wanted is I actually do want, for the update route, I want to be able to say, hey, I only want to update fields XYZ. So like I can say, hey, I just want to update the age and not everything else. So what I want to do is actually just in the update route, I'm not going to make these fields required. That's the only difference. Otherwise, the schema is the same thing. I'm just saying, hey, these fields are not required.
I wonder what the change is.
It's a good question. So I need to make sure that I'm looking at the log. Say send. It's valid. Update pet. There we go. Yeah, it went through. Age is 10. And so I should be able to see everything. Yeah.
So what did you say? Nothing.
If I said nothing, it'll happy. I didn't say that there has to be at least one field you're changing. And actually I'm okay with that.
Okay.
I'm okay with that. So that's how you bring in joy, right? We've done it. That we updated an insert route, we updated an update route. Overall, you see it's not that much code to change, right? It's not that much code to change. I haven't done anything with validating the ID, and I haven't kind of made this easier to maybe duplicate, but you can see it's kind of working, right? So let's talk a little bit about the ID. There actually are a bunch of ways to approach this. And one way we could approach this is we could approach this as saying, well, maybe I'll use joy to validate it, right? maybe I'm going to use joy to validate the ID. Okay? Well, inherently, at least right now, I've got a few things going on. Well, obviously, the ID is not part of the request body, so at least it would need to be part of the data that I'm validating, right? It need to be part of that. The other thing I would need is I need some way to validate an object ID. Okay, and because Joy is agnostic, it works with any sort of JavaScript, anything. Well, object ID is not part of native JavaScript. It's part of the MongoDB library, right? So there's nothing built in to validate an object ID. Is that clear? There's nothing built in to validate an object ID. There are some packages out there that can add it to there. So for instance, if I'm looking at this, if you go to npm and look up for joy object ID, there actually are there are actually a bunch of versions of this because people have made their own packages to do these things. So like there's a joy OID, there's a joy object ID. This one updated 24 days ago. This is version 402. This was 112. This is a year ago. I think this is the one that you had found and mentioned. This is the one that I have used in the past and I found out from via Mosh. After having some, historically I was using the first one, this joy object ID. After having some issues with it last year, I don't actually use that anymore. I don't use either of those. Because what I found out is, I think it's actually easier to just define your own validator. Okay?
I use the second one when
Yeah.
I was messing around with stuff last week.
Yeah.
And I noticed like you don't need to require joy, you can just do joy OID. And then
Well, you have to actually. It forces you the way that it's architectured.
Yeah.
I don't think either of those are a good option, to be honest. Now, before we leave here, I do want to kind of show you how to get to the code. Open. Because oftentimes you may want to look at the code behind there. So if I go to OID index.js, so you can find the code for the OID one, and if we kind of look at what's in here, it's actually really not that much. There's really not that much. It's the actual code behind this package that's it. The rest is just to bundle it up and get it on NPM. And similarly, if I go look at here, same sort of thing.
One more line.
Yeah. So they're actually both really short. And I would propose there's an even shorter way to do this, which is why I would say the best way to do this is to write your own. Okay. So we're kind of at the end of time today, so we'll do that tomorrow. I'll kind of show you how to make your own thing to validate the object ID. Okay. So where I want you to start for kind of the rest of today, you've got about 30 minutes-ish, 45 minutes-ish, and tonight is to start by kind of going through the lab and doing the schema to validate the body. And tomorrow we'll talk about how to validate the ID. If you want to try and look at the documentation for Joy Dev to kind of figure out how to find your own schema validator, feel free to take a look at it and maybe look at it yourself. Cool? Because you can look at the documentation and kind of figure out how to define your own thing. But I would argue I think there's a much simpler version of this than either of those two packages. So if I look at joy dev, and extensions, I think that's it. Here it is, extensions. So I will link that. That is a little bit about where you would need to start if you're going to write your own development. That's kind of the target. So you can look at the documentation a little bit if you need to write your own thing, but we'll talk about that a little bit tomorrow. I'll have to extract and pull out my code. I forgot where project I have it on exactly. So, okay, so you're going to pull up 4.2 and get started on that, and then we'll kind of finish this up tomorrow. That'll have you continue working with this.